Welcome back. In this video, we are going to graph rational functions, but in these particular functions, we are going to end up having to use test points. So it's going to be important for us to understand that when we are working with y's above the x-axis, that's our x-axis and our y-axis, outputs that are positive are above the x-axis. These are positive y's, and outputs that are negative are below the y-axis, because when we do our test points, we're going to test just for outputs, and we're just going to check to see if they're positive, so we know to graph above the x-axis, or negative, so we'll graph below the x-axis. So let's graph our function 3x divided by x squared minus 2x minus 8. Let's go ahead and factor our denominator. We know our denominator can't equal 0, so if I factor this correctly, that would be x minus 4 times x plus 2 cannot equal 0. And then I know x can't equal 4 and x can't equal negative 2. So I actually have jumped down to step C here, and I have found our vertical asymptotes. Our vertical asymptotes occur at x equals 4 and x equals negative 2. So I'm going to go ahead and plot those right away. So I have a vertical asymptote as at x equals negative 2 and another vertical asymptote at x equals 4. So let's go graph this step by step and plot our points and see what we end up with. So let's find our y-intercept. Our y-intercept is our output when we input 0. So we input 0 for x, we output 0, and sure enough we get 0. So we know what our y-intercept is the origin 0, 0. The x-intercepts, well, that's when our numerator becomes 0. So when does 3x become 0? Well, we want to find an output of 0. Well, as it turns out, our x-intercept, we only have 1, and that 2 is the origin 0, 0, and we've already graphed that point. So our x-intercept is the same as our y-intercept. So as we know, our x-intercepts are the only bridges or routes across the x-axis. So I have only one route across the x-axis, and that's the origin. In fact, that's my only route across the y-axis as well. Let's take a look at our horizontal asymptote. We want to compare our largest degree of x in the numerator and our largest degree of x in the denominator. So our horizontal asymptote, we're going to evaluate 3x over x squared, which simplifies to 3 over x. And then we ask ourselves, what happens when x gets really, really big? Well, the larger x gets, whether it's positive or negative, whether they're huge negative x's or huge positive x's, this fraction is going to get closer and closer to 0. So our horizontal asymptote for big x's is our x-axis. It's when y equals 0. So we know that our function is going to as we choose very large negative x's and very large positive x's with asymptotic behavior, we know it's going to get closer and closer to this point. And now we're ready to sketch. The problem is we don't have a lot of information. We don't know if we're going to sketch above the x-axis on the far left or below. It's going to be one or the other, but we don't know which. And this is where the test points come in. Our only options here on the far left is our outputs are either going to be positive above the x-axis or they're going to be negative below the x-axis. So all we really need to do is to test any point in this region. If we test any x, we will know whether to graph above or below. Because if we get a positive output, then we know all our points, all our inputs here will create the similar kind of output, a positive one. Or if we get a negative output, then we know all the x's that we input in this region, all of them will create negative outputs. And we know that because if one of the points is down here, there's no way to get across. We can't jump across this asymptote. So let's take a look and see. This is how we're going to test points. We're going to test any x we want out here. We could test -3. I'm going to test the value of -10. I'm going to put -10 in for x. And this is how you can show the test. Just write, test. And then you can do, this tells me, okay, I'm testing -10. And I know that I'm going to put -10 in for x. And I know that that value is -30. But it's a fraction, so all I really care is that if that numerator is going to be positive or negative. So if I test -10, 3 times -10 is -30, but all I really care is it's negative. And then I'm going to use my factored form. If I put -10 in for my denominator, well, if I put -10 into x minus 4, yes, that's -14, but what I really care about is that factor is negative. And if I put -10 in to x plus 2, again, I know that's -8, but what I really care about is that it's negative. So my fraction then becomes a negative divided by a positive, which of course is a negative result. So I know that when I input -10, my final result is going to be negative. I don't care what the exact value is, just that it's negative. And the reason I don't care what the exact value is because I know what my graph looks like with asymptotic behavior or our end behavior. We know our graph is going to look something like that. Now let's do the same thing on the positive side. Let's go to the far right here and let's test for x's that are greater than this asymptote. So I could pick 5. Again, I'm going to test 10. So let's do a test of 10. So when I input 10 into my function, yes, I get 3 times 10, I get 30, but really all I care about is that the numerator is positive. My denominator, of course, factored form is x minus 4 times x plus 2. And if I put 10 in, I get 10 minus 4. Well, that result is positive. And I get 10 plus 2. That result is positive. And I'm multiplying a positive times a positive here. So I don't really care what my exact output is. All I care about is that my output is positive. Which means if I chose 10, I'm going to get a positive output. There's no route to get to the negative side. I can't get below the x-axis. So what I know about asymptotic behavior, I know my graph is going to look something like that. And that's good enough. That's all we need to know. Now we've got a test in the middle here. Now this particular sample problem has a lot of tests. Some you'll have to test and some you won't. If we had x-intercepts here, we wouldn't have to test. We know we would take those bridges, but we don't have that. So the question is, does my graph go from my y-intercept? Does it go up and to the right? Does it go up and to the left? Does it go down and to the left? Does it go down and to the right? I don't really know what this does. I know it's going to approach the asymptote, but I don't know if it's going to approach it on the positive side. Okay, I don't know if I'm going to approach -2 on the positive side, or maybe I'm going to approach -2 on the negative side. Same thing here. I don't know if I'm going to approach 4 from the positive side, or if I'm going to approach it with negative x's, or pardon me, negative y's. So we have to test. So it's not too tough. We need to test one point in this region because we know if we test one of these inputs and we get a positive input, it has to go this way because all my outputs are going to be positive then. If we test an input on this range and we get a negative output, then we know all of them are negative in this range. So let's check and see what happens. Let's test, let's test 1. So I test 1, and when I test 1, my numerator stays positive. X minus 4 becomes negative because we have 1 minus 4, and 1 plus 2 is positive. So I have a positive divided by a negative, so I get a negative result, and that way I know my graph is going to look something like that. And let's go ahead and we do the same thing between 0 and negative 2. I need to test a value. It may come back down. I don't know. It might go up this way. So let's test negative 1. So when I test negative 1, my numerator is negative. My denominator, I have a negative 1 minus 4 is negative. Negative 1 plus 2 is positive. So now I have a negative divided by a negative, which is a positive result, and my graph is going to head up in that direction. So I have now sketched this rational function, and I've done it with 1 point, 2 vertical asymptotes, and 1 horizontal asymptote, but several test points. So remember now we're only testing to see if our output is positive or negative. So we do need to know, a negative times a positive, that's what we're doing here. A negative times a negative. A positive times a positive. So pay attention to that, and that's how you can graph a rational function. When you're not sure where it's clear to go, you use those test points. And we will see you in class.